Okay, so welcome back. This time we're going to calculate or find a basis for a subspace just described in this fashion, right? So we provide a collection of vectors and they have to satisfy a certain equation. Okay, in its entries. And then you may say, well, haven't I seen this problem before? In fact, we can do the following. Note that W is nothing else but a rewriting of the null space of a certain matrix. What would be that matrix? Well, this one, 3, 6, -1. Why? Let me put it in full detail. This is nothing else but the collection of all those vectors x1, x2, x3 in R3, such that when I multiply 3, 6, -1 against the vector x1, x2, x3, I get 0. But you see, this is exactly the same description as the one that we have here. Equivalent, right? Okay, so now that we have identified W as the null space of a matrix, we can simply proceed to finding a basis for this null space. So let's row reduce. First augment and row reduce. So we have 3, 6, -1, 0. Then from this point, multiply the first row, which is the only one, by -1/3 and obtain by positive 1/3 and obtain 1, 2, -1/3, 0. From this one, well, indicate the following. You have that a vector x1, x2, x3 belongs to the null space of this matrix, well, which is nothing else but W itself, if and only if we have that the entries of this vector satisfy this equation, x1, x2, x3, then the constant here. So I'll just incorporate that system of equations, which is only one here, x1 plus 2x2 minus 1/3 of x3 equal to 0. Of course, I may rewrite this as x1 is equal to -2x2 plus 1/3 of x3, which of course we can write as follows. Using vector notation, x1, x2, x3 is equal to -2x2 plus 1/3 of x3, x2, x3, which we can decompose as x2 times -2, 1, 0, plus x3 times 1/3, 0, 1. What is this saying? Well, then the set defined by -2, 1, 0, comma, 1/3, 0, 1 is a basis of the null space of this matrix, which is nothing else but W itself. So before we finish, because we can consider that this problem is solved, let's capture the essence of what we did. Really, what matters is this identification of W with the null space of a matrix. But then we may say, well, what if I can identify it with the range of another matrix? Well, that's perfect. So we can do this. To find, small note here, to find a basis of a subspace, W of Rn, it is sufficient to identify W as the null space of a matrix or the range of a matrix. Because we have methods to find bases for this, and we have methods to find bases for ranges of matrices. Okay, so with this I finish. I hope that you like it. Subscribe, take care, and make as many comments as you wish. See you later.